Alright, 36. They want us to list the possible rational roots of y equals 3x cubed plus 5x squared plus kx minus 6.
Why is there K?
What do we need to list the possible rational roots? We need, Isabella, look up here. We need this number, and we need this number. None of this matters. So they can put a Q and anything in there, it doesn't matter. Possible rational roots are the factors of the constant divided by the factors, I don't know why I'm talking so loud, of the leading coefficient. Alright, so in this case it'll be the factors of the 6 divided by the factors of the 3. Factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Factors of 3, plus or minus 1, plus or minus 3. So if we write those as actual numbers, possible rational roots, basically I'm going to take one denominator at a time. So I'll take the 1 first. I'll put all those numerators over 1, which would just be those numerators, right? I'm going to write it like this. 1, 2, 3, 6. And then I'll put all those numerators over 3. So 1/3, 2/3, 3 over 3 is 1, I already have that, and 6 over 3 is 2, I already have that. Done. Yes, sir.
The constant's always the last number on
The constant is the last number, yes.
the. Alright.
It's the number without a variable.
Okay.
Make sense?
So is it possible that it's not the last number? Actually,
Yeah, if they don't have it in standard form, I guess it is possible. It's not necessarily the last, it's the number. It's the term without the variable.
Okay.
Okay? Any questions on 36 before we move on? Okay, 37.
Wait, did you just do like what we did like earlier?
Yeah? We want to try to get rid of our fractions, right?
Yeah.
So we're going to make all the denominators the same. Let's factor this one first. What does that factor into? Two numbers multiplied to 12 but add up to -7.
-4, -3.
-4, -3. So this factors into x minus 3 and x minus 4, right? Which is a coincidence.
Okay.
It's a nice one. It's a nice one though, right?
Just
Alright, I don't have the same denominators yet.
oh,
What is this one missing? X minus 4. What is this one missing?
X minus 3.
X minus 3. Alright, so I'll have, don't forget to distribute, 5x minus 20 over x minus 4, x minus 3, minus x minus 3 over x minus 4, x minus 3 equals x minus 2 over x minus 3 and x minus 4. So if I multiply everything by my common denominator, they'll cancel out. Alright, here's where some of you are gonna miss this problem. Anybody know what's gonna happen? What the common mistake is right here?
You don't distribute.
You don't distribute that negative.
Exactly.
This negative goes with all of this. So it's gonna be 5x minus 20 minus x plus 3 equals x minus 2. Some of you are gonna do everything right with that step right there. Don't screw it up, don't be the one. Alright, so if I combine like terms, I've got 4x minus 17 equals x minus 2. Minus the x over, add 17. So that's 3x equals 15. X equals 5. Questions on 37 before we move on? No questions, all right? All right, 38. I did like that, thank you.
Guess what?
The eagle. That's what happens. Okay, Ralph was trying to factor 3x cubed minus 5x squared plus 11x minus 1. Can't factor it, so basically it looks like he did synthetic division with a 1, a negative 1, a 1/3, and a negative 1/3. Where did he get those numbers from?
You got from this math.
He got it from his math teacher.
Oh, you got it from the leading coefficient and the constant.
Yeah, he did possible rational roots. Yeah, that's it, right? There'd be 4 of them, wouldn't there? 1 and 1/3, plus or minus. So, he made no mistakes in his division, but he never got a remainder of 0. So he said, there are no zeros in this, there's no answers. Is that true or false?
Well,
Okay, so explain.
it just sounded false.
Hey, just say
He used it correctly.
he used the right possible rational roots, and he did his division correctly, and he never got 0 for a remainder. So
Right.
there's no answers. What do we call these things? What's PRR stand for?
Possible rational roots.
Which is the answers.
Yeah, those are the
The
possible.
possible answers. Yeah.
What's the second word in that?
Rational. The answer is irrational.
Oh, those are just the possible rational answers.
But it'd be
The answers could be
rational.
irrational, or they could also be
Imagine.
imaginary. That make sense? Okay, so let's pick an answer. Ralph is definitely not correct. What the heck is the fundamental theorem of algebra?
Who knows?
A fundamental theorem of algebra.
Something we should know.
What?
It's a theorem of algebra. And it's fundamental.
Something we should know.
Can't
but
divide by
forgot.
zero thing.
X can never be never divide by 0.
That is true. That's not the fundamental theorem of algebra, though.
I thought I knew it.
It's pretty freaking important. It's called the fundamental theorem of algebra. I'm shocked that they don't teach it to you till almost halfway through algebra 2. You'd think you would learn that in algebra 1, right?
It's fundamental.
It's fundamental, yeah.
Both sides have to be equal.
Yeah, both sides have to equal.
Well, you do the one side, you have to do the other.
No, I remember learning about this, but I forgot.
Okay, the fundamental theorem of algebra says your highest exponent is going to tell you how many answers you're going to have. How many answers is this polynomial going to have? 3, guaranteed. Period.
There was none. So we lied.
Yes. So, Ralph did not know the fundamental theorem of algebra. We're going to have we're going to have exactly 3 complex solutions. They may be imaginary, they may be irrational, but we're definitely going to have 3 answers.
They could be rational. Could be invisible as well. It's like getting crazy here.
All right, are we okay with 38?
Yeah.
39.
Wait, the function for all that's not true.
Okay, here's a question. 38. Somebody asked about D. Why isn't it not D? How many answers is this polynomial going to have? 3. What do we know about imaginary solutions? How do you create an imaginary number? By taking the square root of a negative number, right?
Plus or minus out.
There's always a plus or minus in front of the square root, right?
Yeah.
So imaginary solutions have to come in pairs.
Pairs.
You would not be able to have 3 imaginary solutions only.
Wait.
Now pull them pairs.
You could have 2 and then 1 real, right? Or you could have all real, but that'd be it.
So the answer to that.
The answer is C. Ralph did not know. He said there's no answers.
I
Well,
thought it was like true or
the
false.
fundamental theorem of algebra says, heck yeah, there's going to be 3 answers.
True or false?
Yeah,
I thought it was
Well,
true or false for each, and then
Yeah.
you take
So
one.
there, it's not like you choose an answer, it's just direct
True or
true.
false to the following? Oh,
Yeah.
fine. Ralph correctly used the rational root theorem. He did. True. Ralph was correct when he said there are no zeros. False. Ralph did not know the fundamental theorem of algebra. That's true. He did not know it. The function had all non-real zeros. That would have to be false because you can't have an odd number of imaginary solutions. Okay, 39. The function y equals f of x is shown above, but only in quadrant 1. Graph the rest of the function if f is an even function. The domain of f is all real numbers. Even function, what the heck does that mean?
It's not as that predict.
It's not odd. Okay, good.
Doesn't that predict the where the graph is going to end? Like.
Not in. It's going to tell you what the graph's going to look like, though.
Yeah.
Oh.
Tell me that I was good at these.
It got to like 2, 4.
Oh, wouldn't it be?
So it have to be
the
the contrary,
same,
right?
Like, wouldn't it be the same reflecting the element? Like, just whatever at the top was going to be.
Reflection.
Reflecting across the end.
Okay, if it's an odd function, you might want to write this down because you don't know. If it's an odd function, it's going to be a reflection across the origin.
Oh.
Odd origin, OO, right? If it's an even function, it's a reflection across the y-axis. You might want to write this down.
How can you reflect across the origin?
What that is,
With it,
It would be down here, then like that.
If it's
See what I'm saying?
You said why?
If it's an even function, it reflects across the y-axis.
So origin looks like what?
Okay.
It's an odd function, it goes
It would be, see how this starts there at 1? So it would start at -1, loop out, and then go down like that, if it's an origin.
Oh, okay.
You know what I mean? It would just reflect right across that point.
Yeah.
Alright, so, but this is gonna be even, so. Which variable?
W.
I wouldn't call it a W, I would call it a reflection across the y-axis. Right? What?
if it was reflecting across the origin and you had the function, like the equation, would you do the inverse of it to reflect it?
No.
No?
The inverse is not a reflection across the origin. If you graph the inverse of a function, it's a reflection across the line y equals x.
So wait, what would it look like if it was across the origin?
Okay, if it said it was an odd function, it would be like this.
Oh, so
This would reflect right across that point. This went to there, you see it?
Yeah.
This went to there. What? No. Yes.
So like when you say it reflects across the origin, like how do you classify that as actually like, would that be this almost the same thing as like reflecting across the x-axis?
No. X-axis, this would be down here. You see what I'm saying? Let's do this. If it reflects across the origin, change the signs of the x and y. That fixes it. That does it. So for example, let's say this point right here. What is that? 2, 1, 2, 3, 4, 5, 6. This is the point 2, 6. If you reflect that across the origin, it'll be -2, -6. 1, 2, 3, 4, 5. It'll be right there. That point reflects across the origin to right there. Okay? Yes?
So basically I could complete opposite of it, because it's going opposite the bottom and the bottom, so
Sure.
that's what we need to do.
Any other questions on 39? Even reflects across the y-axis. Odd reflects across the origin.
You said just change the size of the x and y, right?
That would reflect it across the origin, yes. Okay, 40. A car depreciates 22% each year. You own it. If you buy a car for $24,980, then tell the value after you have owned it for 4 years. Round to the nearest penny. All right, so 40. All right, so how much? What's the principal? $24,980. 22% is 0.22 for 4 years. I got $9,246. Anybody else? So the new car you bought 4 years ago is now only worth $9,000. Yes, sir.
do we have to memorize this formula in the first?
Absolutely. They're not going to give you any formulas on the exam. This is honors. You switch to regular before the exam, you get all the formulas.
Seriously, like,
Yeah, of course.
That's not fair.
How's that not fair?
You're
because
not
they're
learning anything, it's
stupid.
all there. Like, you just have to put it in the
They
calculator.
That's
chose
right.
to take the easier class.
Algebra 2 regular is a graduation requirement, period.
So that's.
Algebra 2 honors is on track to take calculus in high school. 2 different classes.
They're the same.
No, it's
Not
not.
the same, but like the same subject.
No, we're trying to get those kids to graduate high school.
Everyone, not.
No. All right, 41. Match. Okay. Oh, you stop it?